greetings all, hope this finds you well as always. It's now time for the latest update from the machine shop, where we're up to and what we're on with. Right, first up, Craig's been back in and he's rattled out yet more new bushes for 76079. So we've got the various new bushes there and their corresponding holes. Craig's got a grand total of more new bushes to make for those, and then all that job's rattled off and finished. There's also one new pin there. That's a replacement for one that was quite badly worn. That also needs it needs drilling and feathering and all the rest of it, so it's ready for use. That pin was made in a pair, which I'll come to in a minute, because we've also got some more which we're making. I'll show you what I mean by when I say a pair. And those are, the other one of those, which was for 80136, that's been finished and was fitted earlier this week. So in other news, 80136. Right, we have several bits of work on that. First of all, these clacks, which I pointed the camera at the other week, and we saw them set up on the horizontal borer with that setup with the two angle plates. Well, they've been recut, as you can see from the nice shiny seat that's in the bottom of that hole. And they've also been lapped to a clack valve, which is this lump here. And as you can see, that's lapped in very nicely. The seat's lapped in nicely. So those are both now ready to refit. There is a cap goes onto these that also laterally locates the clack valve. So those caps will be refitted once the clack valves themselves are back on the engine. But they're done and ready to go. Another bit for 80136 is two replacement motion pins. And this, I said a moment ago, they make them in pairs. And this is exactly what I mean. What we have here is this is all one billet. Now, the reason I do them like this, and this is a trick I nicked off, I learned off another gentleman who works here. The idea is that when you're taking heavy cuts on a piece of round material on a lathe chuck, due to the forces involved, it will try and push backwards in the chuck. Now, what then happens is it pushes, so we have one end holding the chuck, one end supported the live centre. What will happen is, as the work pushes back in the chuck, slides, that live centre comes out of contact with the work, this end of the work starts to vibrate. So first of all, the finish at that end goes to what's it, and second, you start getting dimensional errors in here because the work will flex away from the tool. So the work will start, it won't cut as deep at one end, basically. Now, the idea is, however, if you machine them like this, you don't clamp them here, you clamp them here. So the chuck jaws are pushing up against this shoulder. So as a result, this bar cannot slide back in the chuck. It physically can't. There's a chuck jaw hard up against that shoulder there, so it can't move. As a result, you can take nice heavy cuts. For instance, as what I regard as a heavy cut in this sort of material, you're talking 100 thou depth of cut. So you're putting the tool in 100 thou and just winding it up and taking a heavy cut. You get this lovely, nice traces of blue and purple in the swarf, which tells you it's working properly. And you can do the job in about half the time. Now, so what we have is we have this billet here. This will yield two pins. We'll simply split it in the middle, face those heads back to thickness, and bingo, two motion pins. The bits on the end are the securing collars for them. They've also been bored to be a nice sliding fit on the pin. You'll also see how the securing collar has a chamfer on one edge. That's entirely deliberate. That is so that I know which side of this collar is the outside edge. There's two reasons for this. The first of all is that the inside edge here will locate up against a rod or a fork. Now, so what I need is that inside edge must be square to the hole that's bored in the collar, so you get a nice even contact all the way around there. I ensure those holes are, that face and that hole square to each other by doing it in the same setup. I'll bore the hole out to diameter and then face the end to tidy it up without touching it in the chuck. So those two, that has to be square to that, simple as is. Now, within reason, the outside face it doesn't matter a toss if it isn't square. It doesn't matter at all. I mean, within reason. If it's sort of 45 degrees, it's going to look pretty flaming stupid, and you're probably not going to get the taper pin through properly on both sides. But it's a thou or two out around, or 10 thou. Doesn't matter. Doesn't matter at all, because that's just sitting in fresh air. So that chamfer is there, so I can identify that. So first of all, I can worry that edge is the absolute square edge. The second is, when we come to drill and ream this for a taper pin, you can bet, because we're doing it all by eye, it won't be absolutely thou perfect on the centre line. The drill may have wandered slightly as it was drilled. The reamer may have wandered to follow the drill. It may not be quite in the middle, and so you need to know which way round that collar goes on, or went on rather, when the hole for the taper pin was drilled and reamed. Hence, this little chamfer. So that's the sort of my trademark on these jobs, really. Just so I can always identify a pin and collar set I've made, because they've got that little chamfer on the outside edge. So there you go, that's why that's done. And the idea there is, yep, nice, quick and easy way of making motion pins. In other news, Brian's been back in again, and he'll be in again tomorrow, and he's continuing to do yet more sterling work. I waved the camera at these. These are all spare fittings for Eric, which are now done and ready to go. He's also got these injector caps done and ready to go. He has this little challenge, which is going to eventually look like that, which is a new valve for a steam heat valve, which is that lump down there. It's a bit complicated, that, because the first thing he's actually going to have to do is make a guide and a lapping tool to clean up the seat in the valve. But once he's done that, he can then make a new head and lap it in. So that's the sort of work he's been on with. And you remember I just said very briefly that this was a trick that was taught to me by a very clever gentleman who works in it. And that's a gentleman called Barry Neeson. Now, I owe Barry an apology, if I'm brutally honest, because his work's beautiful. His work's absolutely spot on. It's superb. And yet I never point the camera at it. Now, there is a reason for that. And it's partially due to my own disorganisation. And it's partially due to life. The thing is, myself and Barry work slightly different shifts. And so by the time I'm rounding up a camera to point it at things, Barry's long since gone home and tidied up. The other is very simple. Me and Barry work at opposite ends of the shop, just how life happens. So I'm usually fighting a machine up there, and he's fighting one down here. And so, as a result, I think I'll point a camera at this and say, I think we can all agree, ladies and gentlemen, that Barry Neeson's work is absolutely exquisite. What we have here, this is a valve for it's a replacement valve for the waste shaft lock. I believe off 825, but I could be corrected on that. If it isn't, I apologise, because this all comes to the third point with Barry's work. I very rarely deal with him about it, except for make sure he's got the bits to do it, of course, like ordering materials and tooling and whatnot. And so, as a result, I don't always know the full details of it. And it's my human nature. I don't want to point a camera at something that goes a lovely shiny bit of bronze here, but I don't have the faintest idea what it fits. It just doesn't create the right impression, if you know what I mean. So this is the sort of work he's putting out, and I'm sure you can agree, ladies and gentlemen, that that is lovely. He started from a raw casting there, but he's also making all the replacement fittings for it as well, and the rest of them around here. So if we just wander around here, onto these two trestles, you will see the whole array. We've got a nut, we've got the spindle there, we've got the actual control valve guts there, we've got a gland nut, we've got cone fittings for the pipe work, we've got the actual valve itself, and I'm sure you'll agree, because that, just like all the other valves we've seen, that actually rides on that cam there, just like all the other steam valves we've seen, and I'm sure you'll agree with me, ladies and gentlemen, that work is absolutely spot on. So, as I said, I owe Barry an apology, because very simply, I don't feature his work as much as it deserves. It's no slight intended towards him, or his work for that matter. His work's superb, and I get on very well with him. The simple fact is, he's either packed up and gone home, so I've got an empty bench to point a camera at, or half the time there's something lovely and exquisite on the bench, and I look at it and think, that's really nice, but what the hell is it? Anyway, so thank you very much, Barry. Smashing work as always. So anyway, folks, that's where we're up to, and that's where we're at. I hope you found it educational, informative as always. I hope you found it interesting. And yeah, we're keeping busy. At the moment, we've currently got 8136 is pretty much back together. The lads are weighing it today. The next local on the priority ladder will be 76079. As you've seen, we've got a few bits of small motion to do for that. and then that's pretty much done. Then we're focusing on Eric. Now, Eric's a wee bit more work to do, but it'll fix, it'll do. And then, well, I think by then, suddenly the season will be upon us. So anyway, folks, that's it. So take care, and I'll see you around.